Hello, welcome to Level 3, Principles of Nutrition. And testing it out, this module is all about nutrition. It's all about the things that we put into our body. It's all about how to work with your clients to make sure they've got adequate nutrition to fuel their activity, change their body composition, or essentially have a better quality of life. And we want to kick off today with a little bit of sort of understanding the principles of nutrition. So taking a step back and looking at exactly what nutrition is, what makes it up, and we're also going to look at something called the macronutrients, and we'll get onto those a little bit later on. But first of all, what I want to do is I want to look at all of these organs here, because these are the things that make up our digestive system. I'm going to go from top to bottom, and these are all in the correct order, and this is the way or the path that your food follows once it gets into our body. So, first of all, we have the mouth, and essentially what the mouth is the beginning of the digestive tract, and the mouth is where digestion starts. Chewing the food breaks it down, as we know, into pieces that can be digested. Also, your saliva mixes with the food, and that begins the process of breaking it down so that the body can absorb it. After that, we have the esophagus, alright? And the esophagus runs from the mouth down to the stomach, alright? And it runs next to the trachea or the windpipe. So sometimes we'll swallow something the wrong way. Okay, that's when something goes a little bit down the trachea rather than the esophagus. And yeah, the esophagus really is the sort of, it's a series of muscular contractions that push your food down to the stomach. So the food doesn't just fall down, doesn't just tumble down, alright? It has to be forced down through a series of muscular contractions. After that, we have the stomach, and the stomach is really, I suppose, the best way to think of the stomach is like an empty balloon. So it's a hollow organ or a container, and essentially what it does, it holds the food while it's being mixed with enzymes. So while we're in there, while that food's being stored in that empty organ, it's getting mixed up with the enzymes, and what the enzymes do is they're going to continue breaking the food down into, I suppose, a usable form. And we also have some cells in the lining of the stomach, and they secrete acid, stomach acid, as I'm sure we've all heard before. And these are essentially what help the breakdown of food to happen, and this all happens inside the stomach. After that, we have the pancreas, and essentially what the pancreas does is the pancreas is all about the digestive enzymes. So sort of the first segment of the small intestine is where enzymes break down protein, fats and carbs, but the pancreas also makes insulin. So when we eat, the insulin is sort of like the chief hormone, the main hormone for getting sugar around the body and getting it to the right place, and the pancreas is all about secreting that sugar and making sure that we've got it in the right places and regulated in the right way to be able to transport those sugars or carbohydrates around the body. After the pancreas, we have the liver. Liver has quite a lot of functions, but its main function in the digestive system is to, I guess, process the nutrients that are absorbed from the small intestine. We'll look at the small intestine in a second, but the liver's all about sort of utilising and taking in and absorbing those nutrients so we can get them into the body. And bile from the liver is secreted into the small intestine. That also plays an important role in digesting fat. The liver, again, as I said, has got a lot of functions, but can also be thought of as a little bit like a chemical factory. Takes the raw materials that are absorbed by the intestine and makes essentially all the various chemicals that the body needs to be able to function. So, in come nutrients, out go the chemicals that we need. After that, we have the gallbladder, and the gallbladder stores bile and then releases it to help absorb digestive fats. That's what the gallbladder does. We then have the small intestine, and the small intestine, it has 3 different segments. We don't necessarily need to know what they're all called, but essentially, if you were to take out your small intestine, it would normally be around 22 feet long. So, it's a very, 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 very big organ. And the small intestine is all about breaking down food using the enzymes from the pancreas and the bile from the liver. And also, same way as when we talked about the esophagus, there are muscular contractions going on in the small intestine that force food around. Right? It doesn't just flow around, it doesn't just fall down, it has to be squeezed around. And the contents of the small intestine start out in a like semi-solid type form, so they're pretty much broken down, but they're not fully liquid. But by the time they get to the end of the small intestine, what you'll find is that they are broken down and they're in a fully sort of liquefied form. And once the nutrients have been found and absorbed, the leftover food goes to somewhere called the large intestine, or to give the large intestine its proper name is the colon. And colon's about 6 foot long, so small intestine was 22, colon's normally about 6 foot long. And essentially, colon, it's a big long sort of muscular tube that runs to the rectum. And the large intestine is it's all about I guess getting rid of the waste products. So sort of stool or waste products from the digestive system pass through the colon, first in a liquid state and ultimately in a solid form. The stool passes through the colon, water is removed, the stool is stored in the sigmoid or S-shaped colon until it's until we go to the loo and until it's emptied out. And it normally takes about 36 hours for a stool to get through the colon. Stool itself is mostly food debris and bacteria and essentially stuff that we need to get rid of. And the bacteria perform several functions, such as synthesizing various vitamins, processing waste products. But essentially, that large intestine is all about getting rid of waste and stuff that we don't really need anymore. Then after rectum, rectum essentially is an 8-inch chamber that connects the colon to the anus, and essentially what the rectum does is it receives the stool and then passes it down to the anus. And the anus is the last part of the digestive tract. It's around a 2-inch long canal consisting of the pelvic floor muscles and 2 anal sphincters. And essentially what the anus does is help us to get rid of the waste product that we no longer need. So those are the components of the digestive system, and now you should have a bit of an overview to know what they're all about and what they'll do. So we'll come on to macronutrients, and these are the things that make up the majority of our diet. So I'm sure you've heard of all of these before. We have carbohydrates, proteins, and fats. Okay? And first thing I want to look at is protein, 4 calories per gram. Same for carbs, Look at the fats, alright? The fats are on 9. They are nearly double protein and carbs. And straight away you can see why people who eat a lot of fatty foods tend to gain a lot of weight, because they're taking in so many more calories. So 4 on protein, 4 on carbs, 9 on fats. That pretty much always comes up in the exam, alright? So make sure that you know 4 for protein, 4 for carbs, and 9 for fats. Protein is all about growth and repair and helping to create more enzymes in the body. You'll see sort of athletes or people who work out quite a lot will have more protein because they need to grow and they need to repair their muscles. Bodybuilders in particular will be having a lot of protein because they want to build a lot more muscle mass. But protein is also essential for even your people like your long distance runners, you guys who are doing your more aerobic type activities. They still need a good amount of protein in the diet to be able to recover and look after and repair those muscles. Carbohydrate we use to create energy. We turn it into glycogen and then maybe potentially glucose. And carbohydrate essentially are sugars, and we'll look in those in a bit more detail later on. Then we have fats. To give them their proper name, we call them lipids, but lipids and fats can be used sort of as, you know, both essentially are the same thing. They are used for to give structure in our cell membranes. We use them to look after and help create some of our hormones and look after our nerves. And some fats will also carry vitamins around the body too. A bit more on protein. So, proteins are made up of amino acids, and they're joined in the body by something called peptide bonds, alright? And there are 20 amino acids, okay? 9 of these are essential, and they can't be made by the body. So, there's 20 amino acids in total. 9 of them, alright, cannot be made by the body. 11 are non-essential in healthy adults, but some of these become conditionally essential in certain situations. So what we're saying there is that really the 9 essential ones, we have to be getting those in from our foods because we can't get them from the body itself. The body can't make them. And then of the 11 are non-essential, but they can become conditionally essential. So if you're doing a particular type of workout, if you're really depleting your energy systems all the time, if you develop certain conditions in the body, certain health conditions, they can become conditionally essential, and that means that we need to get them in from outside sources, such as our food, rather than relying on the body to produce them. We have animal products that are complete proteins, so animal products contain all of the amino acids in large amounts. So we're looking here at things like meats, fishes, eggs. Those are things that come from animals. We then have vegetable proteins, so these are soy and quinoa are they're classed really as complete proteins, but then we have other things like nuts and seeds, which do contain some protein, but they're not complete, so they don't contain all of those amino acids. Okay, protein makes for around 15 to 20% of our body weight, and structurally, proteins are an integral component of our cells, that the fascia that holds the body together. Remember, we looked at the structure of a muscle. We know what the fascia is, and that's made up of protein. Functional proteins include enzymes and catalysts, such as hemoglobin or, as we just looked at, adenosine in the ATP. They are all proteins. Hemoglobin, if you don't know, is something that helps to transport oxygen around the body. That's another way the protein is utilised inside the body. So, as you can see, they are essential things to have in our body. sometimes when people talk about protein, and when they talk about diet in general, they'll talk about anabolism, or being anabolic, and they'll talk about catabolism, or being catabolic. And anabolism is making bigger molecules from smaller components, for example muscle tissue from amino acids, and catabolism is breaking down larger molecules to release components, for example breaking down muscle tissue to release amino acids. And depending on your goals, you might want to be catabolic, you might want to be anabolic. If you want to gain some muscle mass, you need to be in an anabolic state. If you want to lose some weight, then you need to be in a catabolic state, alright? And what we can see just below that in the table is some guidance amounts for the amount of protein people should be eating per day. And remember, this is dependent on what their needs are. So, sedentary adult, someone who does no exercise, still going to be looking at having around about 0.8 grams of protein per kilogram of body weight. Alright? Recreational gym user, we're sort of looking 0.8 to 1.5. What you might want to do is they might want to up that on the days they exercise, they might want to go up to 1.5. Days they're maybe not doing so much, leave it down at around about 0.8. Endurance athletes, so the people that do the long distance type stuff, we're looking 1.2 to 1.6 to make sure they're getting enough protein in there to make sure those muscles recover. Growing teenage athletes, someone who's growing quite a lot, someone who needs more protein in their system to be able to facilitate that growth. We're looking 1.5 to 2. And again, that is per kilogram of body weight. Have an adult building mass. So this is essentially your bodybuilding fraternity here. Someone who wants to get bigger. 1.5 to 1.7. And the absolute upper limit is around 2 kilograms per day. There's quite a few studies that suggest anything above that, body just can't process it. There is a lot of conflicting interest, but we're going to go with the 2 grams for this particular course. We'll then come on to carbs. So carbohydrates can easily be broken down into energy to release fuel for activity, as we looked at when we looked at the energy systems. And in our bodies, or the food that we take in, carbohydrate comes in 2 different forms. We have complex carbohydrates, which are starches, and we have simple carbohydrates, which are sugars. All right, and we also get some fibre as well from our carbohydrates. So we have something called the glycemic index. Essentially, what the glycemic index is a scale that rates how quickly a carbohydrate-based food increases blood sugar. So something with a high glycemic index causes a real sharp jump in blood sugar and needs insulin to be released quickly to get all that sugar all around the body. And then we have a low glycemic index, which is foods that release sugar more steadily and more slowly into the body. And sort of, just to go back to the last slide just for a sec, stuff that's going to be high on there, so your high sugar foods, the stuff that releases really quick, it's going to be refined sugars, so man-made sugars, so we're talking stuff like chocolates, sweets, Coca-Cola, alright? Those very heavy, sugary type things. Lower glycemic foods are going to be whole foods, they're going to be starchy based foods, they're going to be things like sweet potatoes, brown rice, brown pasta. Those sort of things are going to have a low glycemic index. And carbohydrate is found in all plant-based foods. So, you know, we've just been talking about potatoes, which is a good example, but also stuff like broccoli, cabbage, green beans. They all contain carbs, not in a great amount, but there are some carbs in there. Fruit is sweeter when we taste it, so we know it's got more sugar in it. So that'll be something that's released a bit more quickly into the body, but they've still got carbs in. We're talking apples, oranges, bananas, pears, those things that taste sweeter, they've got more sugar in. Vegetables, they contain mostly starch and fibre. So again, your stuff like your green beans, your cauliflower, your broccolis, your cabbages, your kales, those sort of stuff are mostly starch and fibre. Whole grain starchy foods are also high in fibre. So when we say whole grain, we mean stuff that's not been meddled around by men, really, or women, but stuff that's not been meddled around with too much. So whole grain starchy foods would be stuff like, normally tends to be brown foods, so brown rice, brown pasta, brown bread, those type of things tend to have more fibre in them. And refined starches have little or no fibre. So that's going back to the stuff like chocolates, your sweets, your Coca-Colas, that type of stuff has really hardly any fibre, but lots and lots of sugar. As we know, I think refined sugars are overconsumed, so the people just have too much of them, and really, as we've seen in America and a lot more in the UK, really, it means that people are getting more obese. They're taking in too much sugar, they can't use it all, ends up being stored as fat in the body, and people are becoming more obese because of the overconsumption of refined carbohydrates and refined sugars. And refined just means man-made. So that's what's going on there. If you are having too many sugars, if you're really abusing it, it can even cause type 2 diabetes. Carbohydrate intake is valuable as a source of energy, and it should be balanced to match physical activity level. So if you're going out and if you are someone who trains really hard and you're doing maybe you're doing an aerobic session in the morning, you're doing something like a bit of running, 2, 3, 4, 5 mile run, whatever it might be in the morning, and then you're hitting the weights at the night as well, you're going to need more carbs to be able to fuel that activity. If you've got someone who is not active, not working out, maybe just walks to work and that's about it, they're not going to need as much carbs because they don't need as much fuel going into their body to essentially power all of those activities that they're doing. So we need to be careful in that we give people the right balance of carbohydrate in accordance to what their activity level is going to be. And that brings us on to fats, alright? Fats are lipids that are solid at room temperature. So normally these are saturated fats. So if you imagine if you had a pork chop, for example, and you put the pork chop under the grill, and you'd all probably know as you grill it, the fat will sort of come out and it'll start to cook. And what normally happens is you'll get a little bit of fat on the top of the pork chop, alright? If you don't eat that pork chop, if you just leave it to go cold, what will happen is that liquid fat will turn solid and it will normally be white. That is saturated fat, or fat that comes from animals. Other types of fats that we have, or lipids, we have oils, and these are normally liquid at room temperature. So we're looking at things like olive oil, things like rapeseed oil, those sort of oils are still fats, and we can take those into the body, and those are what we call unsaturated fat. So saturated and unsaturated, and we'll look at those in a bit more detail. And fats, what they do in the body, as well as sort of providing really insulation and protection, they also carry around some vitamins, so A, D, E and K. And most fats are made up as triglycerides, and essentially what that means is there's one glycerol molecule that holds together 3 fatty acids, and the type of fatty acid in the molecule determine its characteristics. Triglycerides are broken down in the gut to be absorbed into the body and then reformed in the liver, as we said, and packaged into lipoproteins, or essentially cholesterol, the transportation in the blood. So they come as triglycerides, which essentially means there's 1 glycerine and 3 essentially fatty acids coming off it. Essentially that's why it says tri. And then these go into the liver, they're broken down, and they are transported around the blood as lipoproteins, or what we know as blood cholesterol. And what's important, and where a lot of confusion comes, is when we look at these different types of fat. Alright, so we have saturated fats. Alright, saturated fats come from animal products. They have no chemical double bonds. Alright, we have polysaturated fats. These are the fats that come from fish, nuts, and seeds, and they have more than one double bond. That's why they're called poly. Alright, poly means more than one. And we have monosaturated. So mono means one. These monosaturated fats, these come from mostly plant oils. So something like a rapeseed oil would be a monosaturated, and they have one chemical bond. Alright, so saturated, no chemical bonds. Polysaturated, more than one bond, or more than one double bond. And monosaturated is just one. Okay, we're going to have something called hydrogenated fats. These are industrial processed saturated fats made from unsaturated oils, and they're not safe. Alright, stuff with hydrogenated fats tends to be like your microwave meals, your real cheap, nasty, horrible stuff that you shouldn't really be eating. That's where your hydro fats are coming from, and I'd urge you, for you and your clients, to be staying away from those hydrogenated fats. Alright, as we looked at right at the top, fat is twice as energy dense as other macronutrients. So remember when we looked at the 4, 4 and the 9, there's nearly twice as many calories in the fat as there are in the other areas. And choosing natural sources of fat alongside protein limits overeating. So it's alright to have some natural fats in there, okay? But we don't want to be going overboard. Processed foods, where we use the cheap oils and the cheap ingredients, okay, and they have lots of refined starch and sugar, they mean that we're going to be overeating. Alright, so a sensible diet with a little bit of fat and some good protein in there, alright, that's going to mean that we eat the correct amount, so we're not going to be overeating and taking in too much food into the body. When we're eating the cheaper stuff with the cheap fats in there and the cheap sugars, we're going to end up eating too much, we take in too many calories, and we start to gain weight. So, monosaturated fats, so those ones with the one double bond, they can help lower bad cholesterol and maintain good cholesterol. Polysaturated fats reduce levels of both cholesterols, and saturated fats increase them. Alright, so saturated fats come from animal products, so we do need to be careful about how much saturated fat we're taking into the body. Sure thing, you need to get a lot of protein into the body, but there's different ways of doing it, you know. Chicken breast, for example, contains a lot less fat than some cuts of beef. So maybe we should be looking at using the chicken breast, the turkey, the lean fishes to get our protein in, and not having too many high fat cuts of meat. So, all that's helped. We're going to continue to work through the nutrition module and pick up different elements, look at different foods and where we can get them from and what they'll do, and looking at designing and recommendations for your clients. But you should now know what diet is, what healthy eating is, what nutrition is, and we also have a good understanding of the macronutrients, what they all are, and what they all do. Alright, so thanks for watching this one. Hope it was interesting, and I'll see you all again for the next presentation.